bien, buenas tardes.
Good afternoon, everyone. So, as my colleague was saying, I will speak about industrial cybersecurity. Well, this topic is closely related to our last panel, which was so interesting. But I'm going to give a brief introduction to the topic of industrial cybersecurity and the problems we have nowadays. And I will also comment on several services we are developing in INCIBE in order to raise the security level of these control systems. After the last sessions, we can see how the awareness and the concern of the cybersecurity of components, well, we can see how the statistics speak for themselves. And in the end, these threats are raising not only in a qualitative manner, but also in the complexity and in the effort that we have to make in order to identify them and also solve them. I will divide the problem in several parts, and I will treat, on the one hand, the general topic, and on the other hand, the industrial topic. Therefore, we can see the complexity of the problem we have nowadays. So, speaking about cybersecurity, those of us that are older will remember the first viruses that were affecting in a very serious manner at a global level. We can remember this first worm, which was called Morris, that affected all the equipment or a high percentage of the equipment that was connected to the internet. There was not so much equipment connected to the internet, but anyway, this had a huge impact. Afterwards, we can remember the Chernobyl virus. In order for you to have an idea, more than 60 million computers were infected. And at that time, you can imagine more or less how important these kind of viruses were. Afterwards, they started to develop and became more complex, and they were using email in order to spread in a faster way, such as Melissa and the initial worm campaigns at the beginning of the year 2000. And we all remember campaigns such as WannaCry and its derivatives. So this would be the cybersecurity part of this concept of industrial cybersecurity. But we can remember that this was developed only in 35 years, maybe. Speaking specifically about industrial cybersecurity, the experts will speak about the control theory, the control systems, and this is fascinating. You can imagine that in the 3rd century before Christ, we already had the system, the water control system. And later on, we had the first control system that was the first automatic control system that basically controlled the speed of a steam machine. And in 1968, we had the PLC. And as you can see in a visual manner, this explains the problems that we have nowadays. Basically, control systems started before we came here. They started to evolve step by step, and then they met new technologies. And of course, the new functionalities were interesting. So they started to see that when there was a problem in the plant, some manufacturer coming from another country had to invest on the solution and on the cost, and also had to perform an outage in the plant. And the other colleagues from the TI part also had a problem in another point, and the solution was to create an accent point, and then the software was updated and they could keep on working. And of course, they wanted to take advantage of these new functionalities, but they saw that the problem was an inability of update the systems that could allow to connect these isolated cells to another networks. So as you can see here, this image speaks from itself. This could be maybe the year 88, an operator in a control room. For example, when we had these massive viruses campaigns, so what this man thought could think, well, this is a huge problem for our colleagues from IT with all these viruses that they cannot control. And maybe this environment was quite quiet and felt that they were protected, but of course these networks were controlled, they were safe, and they didn't have Windows, so they couldn't have any viruses there. Obviously, these men didn't feel as safe as in the picture for so long, and shortly afterwards some incidents were affecting control systems and they were addressed in a certain way. In the year 2000, this is quite interesting. An ex-employer decided to control the plumbing system of a firefighter's station, and therefore huge quantities of waters were ended up in rivers, etc. And in 3 months, this ex-employee could generate such a catastrophe, and nobody noticed it. And this is the lesson that was learned. So we could say that the organization controls maybe didn't work as they should have, and all the controls were not revised. Another incident that had a huge impact was caused by a teenager, a 14-year-old boy, that decided to start to study the train system of his city and turn a television remote control as a device in order to control train. So you can see here 4 trains failed and 12 people were injured, and you can imagine the consequences that they could have had. And it was so easy to vulnerate our control system back then. Another example, which is quite recent, and we suffered it at the national level, the ransomware campaign suffered by the San Francisco subway. 2 days without service because the ransomware had ciphered 900 pieces of equipment. And one last example that we already know, Black Energy was a Trojan that evolved in 8P in 2015 and created 30 substations in one city of Ukraine and a population of 1.5 million inhabitants. More than 230,000 people lost their electricity supply then. And here we have research published by ESET last week, and here you can see already the evolution of this trend. So what I wanted to say is that part of the modules have been modified, and in the end this reveals that although this is not designed in order to attack an industrial control system, we could see possible modification that could be focused on attacking such a system. And these equipment are quite interesting because in the end this gives them huge capacity and they are always available 24/7. This is why they are so interesting for attackers. And what we can see right now, there are commitment indicators that we can use in order to mitigate this problem. And this is more or less the idea. Here you have a summary of a recent survey. Here you can see some statistics which are closely linked to which was commented in the previous panel. And here are the most common risks that industrial systems have nowadays. So if you have a look at the four first categories, these are problems that are well known by everyone because they come from the lack of updating of the equipment or problems due to segmentation. We have already spoken about this, and it's quite clear that legacy, it's quite complex to have an updating strategy for them. But this is one thing, and another thing is not having any single mitigation strategy for this kind of obsolete systems. And this also applies to access control access. The ideal situation would be to set these controls in order not to use only something that we already know, which is the user and the password, but also take into account something like a token or a fingerprint, and this would depend on the structure that we want to protect. About segmentation, the case is quite the same. At the beginning, we started to build networks, and they were broadened according to the needs, but there are several very interesting tools in order to start to set an organization assets in a very organized way. We can establish what kind of assets should be present in any kind of networks. We also have the policy of protecting based on the characteristics of the assets, etc. So what we could be doing is to start working on good practices. It is true that the certification systems or even certification of products are important, but if we want to have a basic line, due to good practices, maybe we couldn't stop all the threats, but we could reduce all the risks. And now I'm going to tackle another topic and speak a little bit about our working methodology in order to try to develop technologies focused on the mitigation of these problems. The first one would be what we call the National Network of Industrial Laboratories. This was born 2 or 3 years ago in order to identify organizations that could research in this sector and also to collaborate with them. So the first stakeholders would be the manufacturers, and they have to collaborate with us because they are a key factor in order to start our work, and some of them are already working very hard in these first stages. Universities as well, we collaborate with universities because the researchers and scholars give us another point of view that is very useful at the first stages. They start to design concepts, deeper research, and of course the cybersecurity industry that help us to develop these technologies, and in the end the end users that are the industries, and start to validate our technologies and establish new requirements. And we are for 24 laboratories in total. Here we have a good example of collaborative work that we carried out with Allianz 1.5 years ago. It is a passive organization in the lower layers. We are speaking about supervisions and control levels, and what we wanted was to identify actions that could be considered as an attack. For example, updates of it in 1 hour that was not expected, software updates, strategies at an hour that was not planned. So in the end we identified 64 situations that could be an attack and established 3 protocols in order for them not to affect availability of the components. So these are the technologies that we used. We integrated it with an analyzer of anomalies, and we developed several very interesting ways. Another tool, fingerprinting tool, which was integrated in order to identify information of the attacker. It was actually a very interesting work that would be available for those who would like to use it. Another example of cooperation with universities, in this case with the Mines School here in León, would be the design of critical infrastructure. This is to say, with the manufacturers, we design replicas of real industries, and then we can replicate a real attack. This would be one bait or decoy of port or services and industrial infrastructures. In this case, these are detections, and they are trying to have access to this port. And this is another example of event that we compilate. In this case, they are trying to obtain information of the PLC. This would be the first stage of an attack. Afterwards, they will try to see if this is vulnerable and try to continue with the attack until they have entered our systems. We can also detect malware, not specifically in industrial control systems, that goes from a script which is called Cellbot that we have detected in our platform. And this would be one good example of the module that would try to identify the kind of PLC as an initial stage in order to go further and identify the attack. What we are going after with this platform is to identify more relevant attacks. For example, a good example of an attack that uses an exploit that is not still authorized or included, and try to perform an outage of the PLC. And this gives us intelligence and information and knowledge in order to detect new campaigns, new potential problems, and in order to communicate with our target public. Another good service on which we are working on is an analyzer, a vulnerability analyzer for the lower part of the automatization pyramid. It is called ESTILA. It's an European project created in 2014, and what we have done is to develop it in order for it to be useful at a national level. This has a very agile flow. It's only 3 or 4 steps and gets the analysis ready, and then you get back a report with every single vulnerability of the control systems arranged by criticality. This report is very valuable for the head of departments in order to comment and discuss the risks and decide if they assume the risk or start designing a mitigation strategy. And therefore, they could contact with the industry or with the manufacturers in order to solve these kind of problems. But this would be a good tool in order to identify the problem that we actually have and then go down to work. Another kind of tool that we are developing is a Linux distribution that is designed in order to serve in industrial environments. This would be a pioneering project because no other project had this specific aim. This is the initial stage, and it would be very useful because the security responsible of an organization would have all the tools centralized that the bad guys, so to say, also have, in order for them to have documents on good practices, etc. Everything would be centralized. And in order to close my presentation, I would like to present a last initiative, which is called Ics Scan, and the aim is to analyze the exposure level in Internet systems. There are still industrial control systems on the Internet, and we already have the capacity to identify these 5 protocols and the exposure level. We try to go one step further in order not to stick only to detection, but also decide if they are or aren't vulnerable. In order to do so, we notify our target public so that they have the information to identify the problem. Here you have one heat map that shows that the most industrialized areas are the ones that have more industrial control systems exposed in the end. So this was all from me. Thank you very much for your attention, and good afternoon.